So exercise 1-1, lockout or tagout procedure. So this will be your first experiment in the eShop. So exercise objective, become familiar with the industrial controls training system. Understand and perform proper lockout or tagout procedures during industrial servicing and or maintenance operations. So why do we need to have a lockout tagout procedure? According to the definition of this exercise, lockout tagout procedures are measures taken to ensure that a machine or equipment on which the personnel is working is safe and cannot be powered unless every employee is ready. Basically, this lockout tagout procedure is used to isolate systems that are damaged or need to have a preventive maintenance. So therefore, your lockout tagout procedure will serve as a warning sign and also an uh, an accident or barrier for accident. Okay? So bakit? Basically, pag gagamit ka ng lock, therefore you cannot energize any of the equipment unless the lock is removed. Okay? So the first procedure in using or making this lockout tagout procedure is simply identifying energy sources and energy isolating devices. So, dalawa kasi yan yung pwede nating gamitin. Pwede yung mismong source yung patayin natin or pwede nating i-isolate yung device wherein, i-isolate yung machine wherein yung protective device wherein this machine is connected. So, example nyan is your breakers. So, if you have breakers at home, let's say, you have this breaker, your main breaker, and then your branch circuits with breaker. So, our breaker will be its protected device. Sinasabi niya, i-isolate natin. So, these breakers can be isolating devices because we may isolate the system using this breaker. And actually, this breaker is also a protective device. So, if, let's say, a motor 1 is connected in our breaker 1, and motor 2 is connected in your breaker 2, and your motor 3 is connected to your breaker 3, let's say, a convenience outlet is connected into your breaker 4, lighting outlet is connected in your breaker 5, and let's say air condition is connected at your breaker 6. So ang purpose ng lockout tagout is that if let's say this breaker 1 has trouble, ka-trouble siya, which means sabihin natin nagka-short circuit yung breaker 1 natin, syempre magti-trip to. The best thing to do is either lock it or tag it. So pag linak natin to, which means that no one can activate it, even the employees in the employees that are not authorized in your company, hindi nila ma-access to motor 1 na to. And only the authorized personnel may access this motor 1. And also, by identifying how to isolate the system, may also save yung buong company mo. Because basically, pag alam mo kung saan i-isolate yung system mo, so therefore, no need to isolate the whole system wherein papatayin mo to. Pag pinatay mo kasi to, itong buong yan, so therefore, all of the motors that are nagumagana pa, ay mamamatay din. So therefore, masya-shutdown yung company mo. Some of the workers that can still do their work cannot do the work anymore. So therefore, pag nagkaroon ng ganon, this will cause delays. So therefore, the best thing to do is to identify the energy isolating device. Okay? So this will be our energy isolating device. Let's say this will be the breaker. So ikakat natin to, lalagyan natin siya ng lock, or lalagyan natin siya ng tag, or both, lock out, tag out. Okay? So, ano yung contain ng lock mo? Especially pag lock lang kasi yan, so therefore, hindi mo na to pwedeng gamitin because naka-lock siya. Or, pag binigyan mo siya ng tag, let's say tag, lalagyan natin siya tag, ano ba yung mga nasa tag natin? So, warning tags like warning, danger, under maintenance. Yan yung kadalasan nakikita natin sa mga tag na yan. Okay? So, bakit pa kasi nagkakaroon ng accident? It is because of your hazardous energy. So, take note that energy is everywhere. We are surrounded by energy. And this energy can have two forms, your potential and your kinetic energy. Pag at rest yan, naka-potential energy yan. Pag tumakbo yan, it means na meron siya kinetic energy. Take note that these two forms of energy is provided by common types of energy such as electrical energy, hydraulic potential energy, pneumatic potential energy, chemical energy, thermal energy, radiation energy, gravitational energy, and mechanical energy. So, yung mga energy, types ng energy natin, which may become hazardous when it would become or it would injure workers. So, kailangan natin ng lockout, tagout. To make machine or equipment safe, so notify all affected employees. Pag nag-log-out, tag-out tayo, dapat sabihin na natin lahat ng mga employees natin na nakalock or hindi pwedeng gamitin yung machine wherein saan sila nag-work. So therefore, before operating on that, they will have an authorized personnel para i-lock out yung nakalock na equipment or i-tag out yung nakalock na equipment. Okay? So, take note that hindi mo rin magagamit yun kasi naka-de-energize yung equipment natin. Which means that the equipment is not energized. The equipment was isolated from the whole system. So, katulad nito, na-isolate yung buong system natin. Na-isolate siya. So, therefore, you cannot use this one because it was isolated. Out of lockout, tagout. Yung lockout, tagout procedure natin kaya kasi yung primary barrier natin for accident. Okay, pag pinilit mo binuksan yan, so therefore, pwede kang kasuhan ng company mo if you are unauthorized. Hindi mo pinalo yung lockout tagout procedure pag ganun. Okay? So, punta tayo sa procedure ng lockout tagout procedure ng experiment nyo. So, observe lockout tagout, ilalak natin siya. Actually, yung first experiment nyo, we will assume that you will have a preventive maintenance into your system. Let's say, nasira yung system mo, gagawa tayo ng preventive maintenance. So, pag gumawa tayo ng preventive maintenance, natural, naka-lock out yung system natin. The system must be lock out. Okay? Naka-lock dapat to. And then, after that, tatanggalin natin yung, magko-connect tayo, kukonect natin yun, and then we will do several tests into the system, like continuity test, kung may continuity ba yung mga fuse natin, kung may continuity ba yung buong system natin. So pag wala, or kung meron yung system na wala, therefore ito siguro yung mali niya, or ito siguro yung sira niya. I mean, we will troubleshoot a system. So in our first exercise, in our basic setup, wherein naka-set up yung lockout module natin and also our energy sources, we would measure the voltages. Okay? So, in this system, would measure the voltages. So, ano nga ba yung mga voltages na i-measure natin? Particularly, we will have our line to neutral. Line to neutral, meron din tayong line to line voltage. So, balik tayo dito sa system na to. So, take note that pag measure tayo ng line to neutral voltage, meron tayong ito. This will be used to measure the line to neutral voltage. Line to neutral voltage. So, ito yun. This will be measured by voltmeter. So, mapapansin nyo, sa video, where there will be voltmeter there, where i-measure natin to. You can also see that the measurement of the voltmeter is very high. So, take note, in our lab volt, the line to neutral voltage is simply equal to 120 volts. This is in theory. Okay? And then yung voltage ng line to line natin, yung line to line natin later on is this one. Yung L1 and L2. So your V line to line is equal to 208 volts. So take note that the relationship between these two is that your VL is just equal to square root of 3 multiplied by your VLN. Bakit may ganyan? Bakit may line to line voltage at may line to ground neutral voltage? Take note that meron tayong, in our lab volt, we have 3 sources. Okay? 3 lines. Your line 1, line 2, line 3, and then, of course, your neutral. Okay? If you would measure the line-to-line voltage, so ito yan. So, of course, nasa 208 volts to. In theory, pero ang gusto kong ilagay nyo dyan is yung reading namin. Okay, next is yung line to neutral voltage natin is in theory is 120 volts. Okay? So, yung gagamitin nating line dito sa mechanism na to is yung line to line voltage which is 208 volts. And then, gagamitin natin yung transformer in order for that 208 volts, may step down yan, magiging 120 volts, which would be used by this system. Ito yung pinaka-load natin. Okay? So, magiging 120 volts yan, step down. So, yung control transformer natin is a step down transformer. So, take note that this is a 208 volts. Okay? So therefore, we would probably record the reading in our reading, which is basically 208 and 120 volts. In theory. Pero kailangan yung panoorin kung ano yung reading na nandun. So, since naka-upload sa LMS yung makikita namin kung sino yung mga manonood, kung sino yung mga hindi nanonood. So, therefore, pag hindi mo napanood yung video at nag-answer ka lang, so, therefore, automatically cross out yun. Means you did not do the experiment. So, after performing the basic experiment, we would ask to do the voltage measured, confirm the theory presented in the discussion of the fundamentals. Let's explain why. So, probably, discuss ko na yan, which is ito yun. Okay? Next is yung fuse replacement. In our fuse replacement circuit, so ito yung fuse replacement circuit natin. So, take note that this is, if you would do the experiment, you would assume that this circuit is nasira siya or under maintenance or under preventive maintenance, which means hindi siya gumagana. So, pag hindi raw siya gumagana, so anong gagawin natin dyan? I-check natin siya. So, i-isolate natin. Probably, dapat ito, nakalock yan. And then, meron tayong tag. Meron tayong warning tag, which is makikita nyo sa video. So, if naka-de-energize yung system, take note that dapat nakalock yan. So that no one can energize it without the authorized personnel. Yung authorized personnel dito is pwede yung manager, and then kung sino yung gumagawa ng preventive maintenance. Okay? So, in this system, our protective device is a fuse. Yung fuse natin. So, as you can see in the circuit, if I would turn on this circuit. So therefore, we would expect that this load will light. Because basically, yung switch natin dito, which is your emergency push button, is normally closed. So if I turn on the lockout module or turn on the power supply, therefore I would expect that the red light or the pilot light will actuate. But unfortunately in our experiment, the red light would not actuate. So therefore, it means that the system is in trouble or kailangan nating i-troubleshoot or it is under maintenance. So pag under maintenance yung system natin, ang gagawin natin, we would use your continuity test. Note, pag gumagamit kayo ng continuity test, dapat naka-off yung power supply nyo. Or before turning on any power supply, the first thing to do is your continuity test. So paano na gagamitin yung continuity test? So pag nakikita nyo sa video, meron tayong dalawang reading. It's either 0 or infinity. If R is equal to infinity, so therefore, we have an open circuit. Bakit open circuit? So take note that V is equal to IR. Okay? Pag infinite yung R, yung I mo, ay yung R mo, so therefore I is equal to V all over R. Wherein our R is infinite, so V divided by infinite, we will have a 0 current, which means na walang dumadaloy na current sa kanya. Okay? So therefore, it is open. If R is equal to 0, so V is equal to RR, so V is equal to IR. Pag R is 0, so therefore I is equal to V divided by 0, so n number divided by 0 is equal to infinity, which means that your I is maximum. Yon ay shorted. Okay? Pag yung fuse mo is that kinonect natin yung yung ohmmeter, and then yung reading mo is infinite, definitely sira na yan because it is already open. Or the conclusion is that yung pilot light mo nagkaroon ng short circuit, yung load mo nagkaroon ng short circuit, kaya sumabog siya. Pag sinasabi natin short circuit, it is an abrupt amount of current. Okay? Hindi kaya ng resistance ng fuse mo, which was solved or which was identified, so therefore, nakat siya. So take note, pag nakat yung connection ng fuse mo, kahit saan dito, so therefore, walang dadaloy na kuryente dyan, so therefore, your pilot light will be 0. Okay? So, pag gumamit naman kayo ng digital multimeter, pag tumunog siya, means connected siya. Pero pag hindi siya tumunog, it means open siya. Line, open line nga, LO. Line open. Okay? So, V is equal to IR. So, based on our experiment, so therefore, we would expect that hindi siya gumagana kasi nga sira yung fuse niya. Mapapansin nyo doon na chinek ko rin yung connections ng mga to. Baka putol yung wire. Okay? So, kaya chinek din natin yung short circuit test niya. So, pag 0 means shorted. Pag infinite means open. Short circuit is not equal to shorted. Okay? Pag shorted, para yan sa mga wire na may connection. Okay? May connection siya. May connection pa rin siya. Okay? So, pag ito yung tinest natin, so expect na may connection siya. So, dapat 0 yan. So, pag nagkaroon ng infinite yan, ibig sabihin, putol yung wire mo. Okay? So, that would be our experiment 2. Yung fuse, yung pagpapalit ng fuse natin. Okay? Since, in our experiment, makikita nyo sabog yung fuse. Kasi nga, pag tinest natin siya, there is an infinite yung makikita mo. Okay? So, therefore, nire-check namin yung mga bago, it is 0. Okay? So, this will end our first experiment. So, pakisagutan lang lahat to. Tag out procedure. Huwag nyo muna sagutan yung conclusion o yung review questions, guys. Okay? The instruction will be that you should or you would or you must print or you must answer the questions in this lockout tag out procedure na experiment natin, in which nasabi ko naman na lahat. And then after that, ipapass nyo sa akin within your time period. Thank you.